All right, so today what we're looking at, to kind of build on what we said yesterday with area under a curve, is we're going to look at what's known as anti-differentiation. Okay, anti-differentiation. You guys might remember that differentiation is the technical term for finding the derivative of a function. Here we are doing anti-differentiation. We're doing the opposite of that. Okay? So basically here's the process we're talking about. If we know dy dx, what's y? Or if we know what f prime is, what's the original f of x? Okay? And this is helpful in a number of applications. Think about the things that we found by taking the derivative. You know, if we had a position, we could find the velocity by taking the derivative. If we knew a velocity, we could find the acceleration by taking the derivative. So now what the antiderivative, or the process of anti-differentiation, allows us to do is, if we know what the acceleration is, if we know the rate of change, we can use the antiderivative to find what it's the rate of change of. So if we know the acceleration, we can find the velocity. If we know the velocity, we can take the antiderivative, and that will provide us with the position. Okay? So these are kind of inverses of each other. They're not actually inverses because this is not a one-to-one relationship, as we'll see later. Okay? But you do have this kind of process: differentiation, anti-differentiation, or integration. Okay? And then one thing that we want to take note of is some notation. All right? We use the capital F of x to indicate the antiderivative of lowercase f of x. All right? So the derivative of capital F of x is lowercase f of x. All right? As you guys can see up here. All right? The antiderivative of f is capital F. And of course, you can use other letters as well. If you have a g of x, then you'll use capital G for the antiderivative. Another name for this antiderivative is just the integral, not definite integral, but if we just say the integral, or more specifically, we would call it the indefinite integral. Okay, the indefinite integral. And what I want to do today is kind of think logically through this. And before we just start memorizing a bunch of rules for this, I want us to understand and kind of think through and in fact develop two rules, or some of the rules, logically. All right? So let's think through here. Let's say that I have three functions. I have f of x is x cubed. I have g of x is e to the 2x. And I have h of x is 1 over the square root of x, or x to the negative 1/2 power. So I have these three functions here. Let's think through how we would get our antiderivative. And what you're going to have to think about is, all right, how could I get an x cubed from taking the derivative of something? In other words, when I take the derivative of something, I want to end up with an x cubed. Okay. Okay. I'm going to get x cubes. Whatever's going on needs to stop, please, and focus. To get an x cubed, I'm going to have an x to the fourth, right? However, if I take the derivative of that, that's going to give me a 4x cubed. All right? So that's why I need to include this 1/4 times x to the fourth, so that when I bring the 4 out in front to take my derivative, the 4 times 1/4 cancels out to a 1x cubed. All right? So the antiderivative is 1/4 x to the fourth. Okay? Yes?
So the antiderivative gives you the initial equation? Or
Yes. This gives us the function that when we take the derivative, we will get f of x. Okay? So, obviously, checking your answer should be really easy here. Okay? Just take the derivative of what you got and see if you end up back where you started. Okay? Alright, let's try g of x. Okay? The derivative of with respect to x of what would give me e to the 2x. Okay? Well, how would I get an e to the 2x? By taking a derivative.
sort of e to the 3x?
On the right track, but
No, it's the same thing.
okay.
It wouldn't change.
The derivative of e to the power is e to the power, but if I take the derivative of e to the 2x, what does that equal?
Is it the, I think it has to be 2 times e to the 2x. No, 1/2, right?
The derivative would be 2 times
Yeah,
e to
but
the
that
2x.
I mean, 1/3 e times the 2x because we. 1/2.
1/2. Yeah. Because if I take the derivative, I have to use my chain rule, right? So e to the 2x times 2. Alright? So the 1/2 will cancel out the times 2. Alright? Just like over here, the 1/4 canceled out the 4. Right? So, so that means my antiderivative, my g of x, capital G of x, is the 1/2 e to the 2x. Okay? Any questions about that? We following the logic here? Again, you can always double check by taking the derivative of this. Okay? And you should get back to your lowercase g of x, e to the 2x. Okay? Let's try to find our antiderivative for x to the negative 1/2. Okay, so again, we're thinking the derivative with respect to x of what would give us x to the negative 1/2. X to the 1/2. Okay. And then we're going to need to multiply. Yeah, if we took the derivative of that, it's going to be 1/2 x to the negative 1/2, right? So, to get rid of the 1/2, we need to multiply by 2. Okay? That'll get us back to just a 1 x to the negative 1/2. Alright, so our antiderivative is 2x to the 1/2, or 2 root x. Okay? Are you getting the logic? Alright, so there's a little bit of problem solving here, a little bit of thinking. We will learn general rules for both of these. In fact, we'll develop a rule for 2 of these in just a moment, and the other one will be in the homework problems. But let me ask a question though, because one thing we need to consider is, are those the only functions that could be the antiderivative? Is there any other function that I could take the derivative of and get an x cubed?
Plus a constant.
What?
Plus a constant.
Plus a constant. So, you know, here's my 1/4 x to the 4th, right? Let me graph that. 1/4 x to the 4th is going to be like this. It's going to be a parabola that's really wide. Okay, because you have a quadruple root at 0, and you've got the 1/4 that flattens it out even more. Okay, so there's our 1/4 x to the 4th. Okay, but let's say we had a constant. Remember what we said yesterday, the integral or the antiderivative is going to give us the area under a curve, right? So we're talking about this area right here on both sides. Okay? However, if I had a constant like 1/4 x to the 4th plus 3, obviously that's going to change, you know, that's going to change how much area I have. Okay, there's the one side, there's the other side. Alright. Do I have them? No. Okay, so now instead of just this a little bit of area on either side, now I'm talking about all of this area. Okay, so obviously a big difference. So how do we account for that? Well, anytime you are asked for the antiderivative, you recognize that what you got could also have any real number added to it. So, when you give your answer, and this is required, okay, when you give your answer for an antiderivative, you put a plus c on the end. Okay? Because you're acknowledging the fact that that's not the only function that has this derivative. Okay? So here, it's 1/2 e to the 2x plus c. And 2 root x plus c. We're taking the antiderivative and we're recognizing that that could be plus or minus any constant value here. Okay? So, any questions so far? Alright, so at this point, what I want to do is I want to try to come up with a general rule for x to a power. Okay? So in order to do that, we already actually did x to the negative 1/2. We did x cubed. Alright? X to the negative 1/2 they also gave us here. And we said that that was 2 root x plus c. Okay? What I want you to do though is take a few minutes here and go ahead and work with somebody if you'd like. But we have x squared, x to the 5th, x to the negative 2nd power, x to the negative 4th, and this is x to the 1/3. I know it's not real clear here. on the board, x to the 1/3. But take a few minutes and work with somebody to try to find the antiderivative for each of those. And then our goal is predicting a general rule for the antiderivative of x to any power.
For this one.
Okay? So, go ahead and try that. Give you a few minutes and we'll see what you come up with.
Oh, really?
Yeah.
Oh, yeah. You, me. Yeah. You're gonna win. Oh, really?
Charlie.
I know first names. I think
Find out what the derivative
Oh,
is.
she's really good, right?
Do you see it? Do you see your
Well,
derivative?
Mr. Wilstrop,
Hey.
Rodrigo,
See
Mr.
that? Does he ever see that?
Molteruba,
Wait, what?
I don't like that.
Mr.
Weird.
Roma.
I don't care what kind. I just don't
It looks like
like
that.
that makes me
Wait, so after
Yeah, we
I was playing. I trapped the ball. I did like this in my hand.
So here, this is my
So
answer.
I've been
So
really
you
good.
can
So I can play next Monday night, so I can play Wednesday. So,
Good.
X to the 1, it's -1.
X to the what?
That's all.
But how do you?
yes.
Well, you just try to cancel out one, like cancel out third, so it ends up being you're basically the opposite. You're just finding the opposite.
Yes, I could put you in on that.
I'm bad at explaining.
Is there any way I could like not do it before after school, but like in sixth period or during lunch or something?
Wait, what?
Yeah, if you have a study hall, you can certainly do it then.
Oh, yeah. What, exactly what
Should
you're
I do
doing.
it?
It's a 5.
It's a 5?
Let me see here. If you have a study hall, I mean,
100.
where are you?
Oh.
Where are you at?
Okay.
Could I do
So-
it during sixth, perhaps? I would need to double check with my teacher.
Universe times.
Okay. Find out.
Yeah.
Maybe start if you look at the same.
And if not, could I come in
You would use all your.
during lunch?
Yeah.
Okay.
The rule is that, what I feel is that if you have, like, for example, fraction in the book, in developable, like, kind of, like, if you have a fraction in the, component, it means that, the derivative, like, you know, like you're finding the antiderivative is going to be positive exponent, which means that it will have a positive thing to them.
Dude, these seem to be good.
That's really close.
I like it pretty funny.
See, the x is
It's
very
cool.
positive,
The
the
derivative.
exponent is very positive, and
Wait, what?
this thing
What,
is very
please?
positive.
The video
you're on the right track, that's close. I think I have a rule, but it's not clear.
Wait, I wanna.
Like, no, like I wrote like for equation, and I think that one rule is that if you have a exponent, which is a fraction,
Wait,
it's an
I'm
exponent.
calculating.
Or it's a positive fraction. Like for example, if it's an equals fraction, that means that the antiderivative is gonna have a positive fraction with a positive.
Wait, 1 over n times n plus 1.
I bet he's it.
Coefficient.
1 over n plus 1 times n
And
plus
on the other hand, if it's I think positive fraction, then it's gonna have a because like unless it's like a 4 times that fraction or like or coefficient times that fraction.
On the right track, but there's actually a more general,
Why
One
don't
over
more general solution.
1 over n plus 1 times n plus 1.
Either way?
Really?
How's it coming, guys? You guys have.
Oh, yeah. Oh.
What's the point?
Dude.
Exponent and then times the fraction.
I'm just saying.
Why did she go there? Dude, she's so good at that.
1 over n plus 1 times x, the
She's
there's obviously.
That would work.
Oh, wait, no,
It's
it's
like,
just 1 over n.
it's 1 over n. And he said it was further bits of,
Do you have to see?
you can
Yeah.
no, because sometimes you can negative. Because you think like, I'm not racist, so. Personally, it's American.
Wow.
Alright guys, let's take a look at what you came up with, okay? You guys can have a seat please. So the antiderivative of x was x squared times a half, right? 1/2 x squared. How about for x squared? You got
1/3 x.
1/3 x cubed. Good. Alright, how about x to the 5th?
1/6 x. 6.
Good. And how about x to the negative 2?
X to the negative first power.
Okay, negative x to the negative 1st. Alright, how about x to the negative 4th?
Negative 1/3 x to the negative 3rd plus c.
Alright, good. And how about x to the 1/3 power? Did you guys get this one?
Yeah, 3/4 x forward to
3/4 x to the 4/3 plus c. Good. Alright. Does everyone understand how we got each of those? Okay. Alright, so we're trying to predict a general rule for the antiderivative of x to the n. So if f of x equals x to the n, and we'll explain why, but n cannot be -1, then capital F of x equals what? What'd you come up with?
N plus 1.
N plus 1?
Times
Times,
no, like x to the n plus 1.
oh, x to the n plus 1?
Yes.
And then that?
No, the reciprocal.
There we go. It's 1 over n plus 1 times x to the n plus 1. Alright? Or you could also write it, and of course there's the plus c, you could also just write this as x to the n plus 1 over n plus 1 plus c. Okay? So, to put it kind of in our own words, you're going to add 1 to the exponent and divide by the new exponent. Okay? Add 1 to the exponent and divide by the new exponent. Alright, and that's our rule for x to any power. Okay? So now if we have, you know, something like x to the pi, that's okay because we're just going to add 1 to the exponent and then divide by the new exponent. Okay? No matter what that value is. It could be x to the radical 2 power. You're going to have x to the radical 2 plus 1 over radical 2 plus 1. Okay? The only power this does not work for is x to the negative 1, okay? Let's think about that. If I had f of x equal to x to the negative 1, then when I try to take the antiderivative, I'm going to have x to the negative 1 plus 1 over negative 1 plus 1, which gives us x to the 0 divided by 0, which of course is undefined. Okay? Now there is a rule for x to the negative 1, but it does not follow this rule. Okay? So that's why your exponent can't be negative 1. Anything else though, this will work. Alright, any questions, comments, anything? Alright, so what I'm going to have you do now, that was number 1 from the problems on 449. Numbers 2 and 3 are finding antiderivatives as well, but kind of they're giving you a little bit of help here on number 3. Consider how we would take the derivative of x cubed plus x squared and then apply that to 6x squared plus x to the 4th. Alright, so they're giving you a little bit of guidance there. And number 2, you're actually trying to develop a general rule for e to the x. Okay? In this case, e to the kx, where k is some constant. Alright? So I'm going to let you guys take the remaining time here and get started on that. Okay? And that's it. That'll be it for today.